let us go to the next question that we have. And this next question basically talks to us, and we've got two round tables. It's one table and it's got two cylinders. You can say that. So it says to us here, Mr. Ramafule is a carpenter. He manufactures cylindrical wooden tables, which he supplies to furniture shops. To make these tables, he combines two cylinders of different sizes. And that's exactly what I was saying to you guys. Thank you so much, Norma, for this question. Thank you for this question, Norma. It's such a beautiful question, you know. To make these tables, he combines two cylinders. You can see already, this is cylinder number 1. This is cylinder number 2. Those two cylinders that we are working with. Below is a photo and a diagram of one of the tables that he manufactures. The beautiful thing about this particular question is that we are given all the measurements there, so we're not going to be looking for any of the measurements going forward. I love this type of question. Two cylinders, the first one and the second one. So you can see the heights differ, the diameters differ, so already you can tell that we are going to be doing some interesting type of work over there. The first question says to us, before we go to the first question, please take note of the radius. Okay, there's 3 ways in which they can represent the radius. It's either you're just given the sign of the radius. Sometimes they can say to you, use pi is equals to 3,14. Sometimes use pi is 3,142. So it's very, very important to use what has been given to you. If the pi has not been given to you, pay careful attention to what I am saying right now. If pi is not given to you, use the pi as it is in the calculator. If pi is given to you, use the pi exactly as it is given to you. And the reason for this is so that you get the same answer as the examiner, okay? You don't want to be getting a different answer to the examiner, because then it's going to make everything wrong, okay? And you know, one of these things where if you get 1 wrong, then 2 might be wrong and 3 might be wrong, and so on and so on. So let's look at the questions here. Beautiful questions that we do have here. And the beauty about these questions is that we're given a formula throughout. I was like, oh my gosh, okay, formula. We've got a formula over there, a formula, a formula, a formula, and a formula. So there is absolutely no reason why you should be getting any of that incorrectly, okay? There's no reason. Please do not disappoint yourself in that. So the beautiful thing that you can also go do now is learn how to use your formulas. The first question that we do have from this particular setup is asking us to please calculate the area of the top of the table. You may use the following formula. So if we're looking for the area of the top of the table, we are looking for this particular, so this is what it would look like. You can go and redraw it for yourself. I'm just going to call that 30.1. If I have my circle over there and I'm asked for the area of that circle, and I'm told that the formula I need to use has to be area is equals to pi radius square. Look at this particular circle that we have been given. We have not been given our radius, but what do we know about a circle? We are given the diameter. Let's go and put in the diameter. We are given a diameter of 150 centimeters. You need to know the relationship between diameter and radius. And it's very important because sometimes you will be given the diameter, sometimes you'll be given the radius, and you are asked for the diameter. So you need to be super vigilant when it comes to such questions. So now we know that the diameter is 150 centimeters, and we know the relationship between the diameter and the radius is that the radius is half of the diameter. So in this particular question, look at how I take the values and I plug them into the formula. So it's going to be pi, and we know pi is 3,142. We've been told that the radius is half of this diameter. So it's going to be 150 divided by 2 square. That's super, super important for you to be able to do. Let's go and plug that into our calculator. So what do we know? We know that it's 3,142 times, close bracket if you want, but it's important that you do close your bracket. There we have our fraction divided by 2 square. Stunning. So we have our answer happening over there, and our answer is going to give us 17,673.75. Why is it such a huge number? Let's go write that number down. 17,673. I'll explain everything just now. 17,673.75 centimeter square. The reason why we are sitting on our thousands already is because we're working with centimeters. Don't panic, okay? It's very important for you to be able to visualize this. Is this making sense to me in real life? It's in centimeters. If we were talking meters, we'd be talking a different story and we'd be converting. So in this particular case, we are given everything in centimeters. What have we done now? We've calculated the area of the top of the table. The next question now says to us, calculate the area of the base of the bottom part of the table. And they're asking us now and telling us that we do use the same formula for the area as well. So now we've calculated the top part, which is way bigger. And now the expectation is that the area of the bottom part needs to be smaller. Let's go and calculate that using the very same formula. 30.2 area is equals to pi radius square. We know that our pi is 3,142. We know that our radius for the bottom part, let us go and look at the radius for the bottom part of our table. The diameter is 50, and because the diameter is that 50 over there, we know we're going to be using our relationship, and we know that our relationship between diameter and radius is that the radius is half of the diameter. So I take my 50 divided by 2. You do get a mark for that, by the way. So please, please, please don't waste your marks away. I'm going to plug that into our beautiful calculator. 3.142 times 50 divided by 2 square. And look at that. Already, it's way smaller than the top part. 1,963. 1,963. Let's go look at 75. Please do not forget your unit of measurement. So now you see the expectation that I was talking about. The bottom cylinder is smaller than the top cylinder. So obviously, because it's smaller, the bottom area is going to be smaller than the area that we have at the top. Let's look at the next question. Beautiful, because we already have all our formulas given to us. The side thickness of the top part of the table will be painted with red. Okay, so we know that. Calculate the area that will be painted in red. You may use the following formula. Beautiful. Another formula given to us. Let's go and see which part they are talking about. It's important for you to be able to know what exactly you are calculating. So in this particular case, the red part, The red part is going to be this part, okay? So all around here, we are going to be painting it red. So we want to know the thickness that they are talking about is this thickness over here. This is the thickness. The thickness is the height. So look at the words that they are giving to you, because that's very important. That's 10 centimeters. Let's go down and plug that into a formula and use it. 30.3. So the area in this particular case, 2 pi radius times the thickness. I'm going to call that the height, because the thickness and the height are one and the same thing. 2 times 3.142. Remember, that's already given to me. That's pi times the radius. We know that the radius is going to be 150 divided by 2, which is 75. Okay, but I'm going to just plug it in like that. Times the height, which is 10 centimeters. Everything here is in centimeters. So there's no conversions that are required of us in order to do this particular calculation. So let's go put that into our calculator. So that's going to be 2 times 3,142 times, I'm going to put that as a fraction, 150 divided by 2. It will give you the same answer, times 10. Nicely put there. That's 4,713. 4,713, and that is supposed to be centimeter square. Do not forget your unit of measurement. It's super, super important for you to write your unit of measurement at all times. 30.4. 30.4 is the next question, and it's asking us, it says to us, the base of the bottom part. Guys, anytime you are asked for the base of anything, it's what it sits on. If you ask for the base of a box, it's the bottom part where the box is going to be sitting. Okay, so it's the bottom part. So the base in this particular case is going to be the bottom part of that cylinder. So it says to us here, the base of the bottom part, which serves as the base of the table. So we've got that information already. Will not be painted. The cylindrical part will be painted with white paint. So now we're talking about the bottom parts. It says to us, calculate the area that will be painted white. You may use the following formula. Again, we're given a formula. Isn't this beautiful? There's no sweating in this particular case. So now we want the bottom part that is going to be painted. We've calculated the top part that's going to be painted in red. Now we want the bottom part that's going to be painted in white. We're using exactly the same formula. It says to us, area is equals to 2 times pi times radius times height. Okay, so I've put those multiplication signs on purpose in there. So 2 times 3.142 times the radius, and we know that it's 50, so it's going to be 25 because it's 50 divided by 2 times the height, and the height in this particular case is 70. And let me just show you what we are working with in terms of the picture up here. So the height in this particular case is going to be the 70, and that is the thickness, okay? And then I use that for us to know what the diameter is in order for us to find the radius. The part we are going to be painting is this part over here. See how I'm making everything super messy so that I can be able to calculate and visualize what I am doing. Perfect. Let's go. 2 times 3,142 times 25, which is the radius, times 70, which is the thickness, gives us 10,997. 10,000, let me just make sure that I'm using the same color over there. 10,000 997. Always double check your answers. It's area, so I am going to be using square. Please be super, super careful, super vigilant in terms of your unit of measurement. Okay, so we are using centimeters, but because it's area, there has to be that square there at the top to show that you do understand that we are working with area. When you are working with volume, make sure you are using your cubic meters, cubic centimeters, so that you can get all your marks. Sometimes you are getting a mark for just saying that is what it is. The last question coming from Norma says to us, calculate how much wood is used to manufacture this table. Give your answer in cubic meters. Look at that. They're even giving you the unit of measurement that you need to use, but you need to be super, super careful when it does come to such things, because sometimes you're not given the unit of measurement. So you need to make sure that you are now using the correct one, even if it's not given to you. Okay, be super careful in terms of that. You may use the following formula. Again, we're given a formula. Like I was saying, this is such a beautiful, beautiful question that has all these beautiful formulas that we are given. 30.5. Let's go. Volume is equals to pi radius square height. So we're looking for the amount of wood that is going to be used to manufacture this table. So we are also told that this table is wooden throughout. So the top part is wood, the bottom part is wood, but we now want the total volume because we want to know how much wood is going to be used for the whole table. So we are going to be doing it separately. We're going to find the volume for the top part, find the volume for the bottom part, and then we're going to add the two. Okay? In this particular case, they didn't say to us the total amount of wood. They just said to us the wood. So you need to also be careful when you're looking at such questions. So let's go and find number one, find number two, and add the two together. So the first volume I am going to call V1 and plug in all my values. The radius of the first one we did say is 75 square and the thickness is 10. So whatever answer that I'm going to get here, I'm going to be adding with the second one. That is 3,142 times 75 square times 10. There we go. That is going to give us nice big number. That is going to then give us 176,737. So that's 176, okay? 737. Nice big number, ne? 737. Let's now look at 0.5. Why is it such a huge number? Because it's volume. In order for us to understand all of this, we need to know what volume is, we need to know what area is, we need to know the difference between the two. Okay, so 3.142 times, we know that the radius in this particular case is 25 square and the thickness is 70 because that is the height. Let's go plug that into our calculator. Also still expecting quite a big number because we are working with volume and we are working with centimeters. Okay, it wouldn't be as big if we were working with a bigger unit. Let me just put it that way. 70. Big number again. That's 137,000. So in this particular case, so 137, you can tell already the volume at the bottom is smaller than the volume at the top. 46,400 462, 462, I think that was 0.5, stunning, 0.5 centimeter cube. Now I take these two and I add them together. So that's 176,300, 737.5. When you work with big numbers, please be super careful. They will dribble you sometimes and you will be putting in the wrong number basically. So let's go look at the total. Just going to move that just a little bit. It's 176,737.5. Oh, sorry. Look at what I did there. Look at this mistake that I'm about to rectify. I said multiply. You add them together. I would have gotten a number that's bigger than anything. So we add those two together. Plus 137,462.5. That gives us 314,200 centimeter or cubic centimeter. Let me tell you why we're getting such big numbers. The reason why we're getting such big numbers is because we're working with volume. Volume is the space that's inside the container, the space that's inside the shape. Okay, so whenever a shape has height in it, whenever a shape has a base and height, it's got area and it's got height, that area has a volume. It means you can put something inside of it. And in this particular case, it's a big slab of wood. So the area is going to be huge. I mean, the volume is going to be super, super, super huge. Okay, that's why the numbers we are working with here are big. And they're big because we are using cubic centimeters. If we were using cubic meters, it would narrow our number down by 2 digits. If we were using a unit even bigger than that, we would be using, our number would look even smaller than that. So it's be super, super careful of that. Don't be scared when you're using centimeters and you're coming across huge, huge numbers. Do not be scared.